Let's say you've got a triangle 3, 4, 5, and you enlarge everything by a factor of 2. So this length will be 6 and this length will be 8. The question is, just because you doubled this length and you doubled this length, does the diagonal length, does the hypotenuse get doubled? The question is, does it become 10? And we don't know. So let's just try and check. So when you double this, it would be 6. It would be 8. Use Pythagoras to work out this diagonal length. So that would be x squared plus x squared equals 8 squared would be 64. This would be 36, and then add these two together. That would be 100. So x is actually square root both sides. That would be 10. So x is actually 10. So in this case, it works. It turns out that if you double the length, if you enlarge everything by a factor of 2, the diagonal length also gets enlarged by 2. And let's try and understand why that works. So to understand why, let's call this x, and let's call this y, and let's call this w. So if you double everything, this length will be 2x, this length will be 2y. Use Pythagoras to work out this diagonal length. So let's call this diagonal length, let's just call it p. So p squared equals this thing squared, which will be 4x squared. This thing here will be 4y squared. So p is really the square root of that. So p is really the square root. Now, to understand, to see how much it grows by, you need to do this. Factor out the 4, so that would be like this. 4 bracket x squared plus y squared. And then you know one of the properties, remember this thing here? If you're trying to square root one thing times another thing, that would be the same as square root of one thing square root of one thing times the square root of the other thing. So here you've got 4 times the bubble. So that will be square root 4 times the square root of the bubble. But then the square root of 4 is 2. So what that means is, if you look at this, p is actually twice the old length. Don't forget, the old length was x squared plus y squared square root. So you can see that it grows by 2 as well. So the moral of this video is that if you double this and then you double this, the diagonal length also gets doubled because of this. It's twice the old length. So I hope you can see that, okay?